Hey, Miss Duncan, we're back with more stoichiometry.
Yay!
I'm so excited.
Me too.
So, how do you think everybody's doing so far on the first few problems?
Well, it seems like they're a little confused, but they're getting it.
Yes, I agree. It takes a little practice, lots of practice, to do stoichiometry, but we're going to do that. And actually, that's the whole reason behind this video, is to work some more examples. We're going to work one where it gives them the entire equation like they've been working.
All right.
And then I'm also going to work two problems where it doesn't give them the equation. So they're going to have to figure out the equation and then work the stoichiometry.
Right.
And that's part of Objective 8-2.
Yeah.
So we're really kind of plugging along, but this will be several more examples. Then, of course, we're going to help them in class when they start working on these. All right, well, let's get started. Here's our first example, and let me get a pen to write with here. We are going to, what color should we write with today?
Pink.
Pink. How about this little dark pink? We'll see how that kind of works.
All right.
All right. So here's the first example. Like many metals, aluminum will react with the halogen. Remember the halogens are like bromine, chlorine, iodine, to give a metal halide according to this reaction. So when you have a metal combined with a halogen, it's called a metal halide. And so here I have aluminum reacting with bromine to form aluminum bromide. Yeah, pretty cool stuff there.
Like this.
Okay, so we want to know what quantity of bromine in grams do we need for this reaction to completely react with 2.56 grams of aluminum.
Okay.
So, first step, balanced equation. Do we have a balanced equation?
Yes, ma'am.
Yes, we do. Check. Okay, we've got that balanced equation. Cool. Okay, second step is to write those amounts underneath the equation.
Yes.
And so we're going to write that way up here, I guess, or we can rewrite the equation if we wanted to down here to have room. But we know we're starting with 2.56 grams of aluminum. I've got to turn my little pad here so I'm right in the same direction. Here's the screen. And we want to know how much bromine in grams that's going to be. Okay? So I'm going to actually move this down here so that I have room to write. So I have my 2.56 grams of aluminum. And then the other part of my proportion was my X, and it's grams of bromine that we're trying to figure out. Okay, the next step, again, is we try to figure out what is the mole ratio from the equation. That's what goes on the bottom here, the mole ratio from the equation. So moles of aluminum, according to the equation, is 2.
All right.
Okay, now I need to make that into grams because whatever unit I have here, I have to have here at the bottom. So this needs to be 2 moles, but represented in grams of aluminum. So what do we need to do to figure that out?
We have to go to our periodic table.
Yes, we do. And we need to find out what is 1 mole of aluminum.
It is 26.98.
26.98 grams. Okay? So if we have 2 moles of that, if we double it, that'll give us
53.96.
And that's what goes on the bottom here. Excellent. Okay. So that's going to be grams of aluminum, and that is equal again to that molar quantity from the equation. Okay, we've got to do the same thing with bromine over here. So we want to know what are the grams of bromine. This should be Br2 right here. So we know that 1 mole of bromine molecules is equal to
159.8.
Okay, and you got that because you took 79.9 and multiplied it by 2, right?
Right.
Okay, because 1 bromine is 79.9. Since there's a little 2 there, we've got to double it. And so that's 150, say it again?
9.8.
9.8. Okay. Now, that's 1 mole. The equation says we need 3 moles. So we've got to take this number and multiply it by 3 now. So 159.8 times 3.
479.4.
That's pretty big.
Yeah.
Okay, so I'm going to come put that over here in my ratio so that we can do the calculation here. Okay, we're done. We're almost done. We've got our proportions set up. So now all we have to do is just cross multiply and divide. So 2.56 times 4.79.4 divided by 53.96. Sorry about that little glitch there. My little thing wants to come on for some reason. 53.96 grams. And that's going to equal...
I think it may have stopped recording.
There we go.
All right. 22.7.
22.7 grams, and that's bromine.
Yay.
Right there. All right. So hopefully this should be pretty easy so far. I think maybe after working some of the other problems they've done, they've probably got a good handle on this. Okay, so let's try another one. We're going to go on to the next problem here. Now, the next one's going to be a little tricky, though.
Why is that?
Well, do you see anything missing from this picture here?
Gasp. We don't have our
We don't. We can't do anything with that balanced chemical equation. So can we figure one out from the information that they gave us here?
Heck yeah.
Well, let's see what we can do. It says bromine can be prepared by adding chlorine gas to an aqueous solution of sodium bromide. So we're going to write the chemical equation for this. We've got Br, it's diatomic, so I've got to put that Br2. And bromine, if you look on the periodic table or you look it up, you find out that bromine is one of the very few liquids when it's room temperature. And it is added to chlorine gas, and again, Brinkelhoff, it is a diatomic molecule. I made a mistake.
Yeah,
I wrote this as a reactant, and it should have been a product.
Yeah.
Okay, so we're going to have to erase this. My bad. Okay, I still need somebody to show me how to use the keys to do undo. Okay, I erased. Let's try this again. My bad. Okay.
See, even the pros have to read the question carefully.
That's right. Okay, adding chlorine gas. So we're going to take chlorine gas plus, I forgot my little G for gas, aqueous solution of sodium bromide. So we got to write a formula here. Okay, so I know that this is a metal and halogen, so I'm going to have to figure out what those charges are. Sodium is +1. Bromine is -1, so this is a pretty easy formula to write. It's just NaBr, and it's aqueous. Okay, now I can write my Br2.
Because that's one of our products.
Yes, and since I know that this is what kind of equation?
Simple replacement.
Yes, a simple or a single replacement.
Oh.
This chlorine right here is going to come in and replace bromine, and which will leave bromine by itself, and we know it can do that because bromine's like at the bottom of the activity series of halogens, so pretty much any other halogen can replace it. And it's going to be bromine plus sodium chloride, our good old friend, table salt. Yeah. So, of course, that's going to be a solid. Well, technically it'll be aqueous because we still have water in here since this is an aqueous solution.
Yeah.
But we could boil off the water later and get
find
the
out how
solid.
much,
Yeah.
yeah.
Okay, so I think we have an equation here. Now we just need to balance it.
All right.
My chlorines, I've got 2 here, so I need 2 there, which means I'm going to need a 2 here to get my sodiums to balance, and now my bromines are also balanced. So now I have a rockin' balanced equation.
Heck yeah.
All right, I know we need our, no. Anyway, so we, now it says how many grams of bromine are formed if 25 grams of sodium bromide and excess chlorine. That means you have all the chlorine that you need to react. So you have plenty of it, you're not going to run out of it, but I only have 25 grams of this. So we can already tell just by looking at this that this is going to be my limiting reactant. They haven't quite learned what that is yet, but they will soon.
Yeah.
They probably figure out what it means pretty easily.
Yes.
Okay, so I'm going to put my 25 grams of sodium bromide underneath there. And I'm trying to figure out how many grams of bromine. So I'm going to put my X for grams of bromine right there. And this is pretty easy now that I have my balanced equation and everything. I know that there's 2 moles of sodium bromide. I'm going to put that in parentheses over here. 2 moles of that for every 1 mole. Whoops, I missed on my parentheses there, but 1 mole of bromine. So a minute ago we said that 1 mole of bromine molecules was 79.9 times 2, right?
Mm-hmm.
Which was 159 point, what was it again?
8.8.
Okay, so that's easy. I'm going to put that right underneath that X right there. 159.8 grams. Okay, so now I don't need this anymore.
All right.
Okay, I need to know 2 moles of sodium bromide now. So I'm going to have to add sodium and bromine together. We know 1 bromine is 79.9 grams.
And sodium's 22.99.
99. Okay, would you add those up for me, please?
102.89.
102.89 grams. Now that's for 1 mole. So if I double that, then it'll give me 2 moles up here.
205.78.
Okay. I think our proportion is set up. We know that that's 2 moles, so I don't need that anymore. 25, we're going to multiply that by this 159.8 and then divide by 205.7. So X is going to equal
19.4.
19.4 grams of bromine should be produced. All right.
All right.
So working the problem is the same. The added layer is that they have to figure out the correct chemical equation.
Yeah.
Sometimes that can be a little challenging, but we know that they can use their notes, their types of reaction sheets, very helpful for that.
Mm-hmm.
And then if they're really stuck, then we're here to help. All right, one more example. In order to do this next example, we're going to show them a little video because it's an actual experiment we did the other day.
Yeah.
Okay, so I want you to watch this video, and then we'll come back to the example in just a second, okay? Hey, Miss Duncan, what are you up to?
Well, Miss Shunky, I'm about to perform an experiment with this lighter.
Well, aren't lighters like banned from school or something like that?
They are, but it's okay because I got it from the lab and I'm going to be performing an experiment.
Oh, okay. Yeah, you're right. That's legal.
All right.
Okay. So what are we going to do?
Well, we're going to be looking at the stoichiometry of burning butane and seeing how much butane will react with oxygen to form how much carbon dioxide.
Okay, cool.
All right.
Well, what's the first step?
First step is we've got to weigh our products. And that gives us 16.932 grams.
Oh, good. I see you're writing out to the precision of the scale you're using, all 3 decimal places. That's good.
All right.
Okay.
Now I'm going to perform the reaction.
Sweet. What a cool reaction. You're going to play some music, feel like you're at a rock concert. You know, you probably didn't ever go to a rock concert or use a lighter, did you?
No, I didn't. I used my cell phone. That's okay.
Yeah, today's kids use cell phones. When it was my age, we used lighters. No. Okay, so we're going to burn that for a little bit. Now, once we finish burning it,
we're going to weigh it again to see how much of butane we used. Only a little bit.
Only a little bit, but there was a difference.
All right.
All right.
And that gives us a difference.
So we're going to subtract those 2 numbers to find out how much butane was actually used up, right?
Yes.
Let me get a better angle there. 0.057. Not a whole lot, huh?
Mm-mm.
No, but that's enough for us to do some calculations though, right?
Yes.
All right, here we go.
Alrighty.
Okay, well, we're back. So, exciting reaction that you did there.
It was pretty awesome.
I bet they cannot contain their excitement over watching you light a lighter.
I know. Such talent in these hands.
Yeah, but we're going to do some cooler experiments with them. Like they're going to, one of the things I'm excited about is that they're going to do some stoichiometry about their fingerprints. So
that's going to be really fun.
Yeah, a little CSI. So it's a pretty cool little lab, and they'll be doing that hopefully after they've watched this video. It should be the next one. Mm-hmm. Okay, so we calculated 0.057 grams of butane that you burned. That was not very much, but it was kind of a lot for that little butane lighter.
Yeah.
Okay, so the first thing we need here is what? We're missing something.
Equation.
That's right. And the one thing that will help us figure out this equation is knowing what kind of reactants we have and what kind of equation we're going to write. And since I have C4H10, that's a hydrocarbon. So I should immediately start recognizing at this point that I have what kind of equation?
A combustion
Yes,
reaction.
and the fact that you were burning was a good, clue of that too. So this is a combustion reaction. So I know that all combustion reactions are going to use oxygen to burn. And we said that right here. They're going to react with oxygen, and they're going to form two products. One of them is carbon dioxide, and that's a gas. And the other one is water. And sometimes that's written as a gas, or it could be a liquid. It's really water vapor at this point. So now we just have to go in. We've got a skeleton equation here. Now we just have to go in and balance it. So we've got 4 carbons here, so I'm going to have to put 4 here. This is going to be one of those tricky ones, I bet.
I think you're right.
And then I've got 10 hydrogens here, so I'm going to put a 5 here, which is going to leave me with an odd number, so now I need to double everything. So instead of 5, this should be 10. Instead of 4, this will be 8. And that makes this one, that's
13.
13. So we had 26 oxygens on the other side. Oh, and I've got to put a 2 here because we had to double that. Okay, we got a balanced chemical equation.
Heck yeah.
So 0.057 grams of butane was what we burned. And we wanted to know how much carbon dioxide in grams did we make. So, just like with the other problems, we have our knowns and our unknowns on the top, and our mole ratio goes on the bottom. So, we need to know what 1 mole of C4H10 is going to equal. So, that's 4 carbons and 10 hydrogens. Carbon's 12, so 12 times 4 is 48. And then we're going to add 10 to that, so it's going to be 58, right?
58.
That should be a pretty easy calculation. Okay, and then if I multiply that by 2, since I have 2 up here in the equation, I need to put 2 moles on the bottom here. So 58 times 2 is going to be 116. Okay, so 2 moles is equal to 116 grams of C4H10. Okay, and then I need 8 moles of carbon dioxide. I'm going to put that in parentheses over here to help me remember that. We know that 1 mole of carbon dioxide is going to be equal to carbon plus oxygen. There's 2 oxygens. So it's 12, and then 16 times 2, which is 32. And that's going to add up to 44, right?
Mm-hmm.
Okay. Now I have 8 of those. So 8 times 44
gives us 352.
352 grams of carbon dioxide. Again, that's the amount from the equation. For every 116 grams of butane, I should be able to produce 352 grams of carbon dioxide. So I'll tell you another thing that's nice for these mole ratios when you see that is that, you can see that when I look at this, I have a 2 to 8 ratio. which is the same as about a 1-to-4 ratio. And you can kind of see that here. You have 1, which is 116. Let's round that to 100. 100 is almost to 400. So that's almost a 1-to-4 right there.
Just about.
Yeah. So, okay, so we have this, and we're going to do 0.057 grams times 352 divided by 116.
And that'll give you 0.329.
X is equal to 0.329 grams.
I lied.
No?
It's more than that, but that's okay. That's close.
Oh, 0.329, 0.329.5. So it should really be 3 or 30.
Yeah.
3, that's okay. I'll put a little call out on here so they can read that better. And that's carbon dioxide.
All right.
All right. Okay, so we worked a couple examples where they had to write the equation. We worked one just like we've been working. And I think these 3 examples are, good extra practice. So good luck on working your stoichiometry problems. 8-3 is your next video, and we're going to be talking about limiting reactants in that video. So we'll see you then. Bye. All right, except for all the